Alright, this is Jared Lucas, and this is the tutorial on how to use the JGrasp viewer canvas. Alright, so the first step, how to install this software. First, we will go to JGrasp download, we'll search that, hit JGrasp homepage, and then on the left side here, we should see a plugin for Eclipse. Click that, scroll down a little bit, and then for the installation right here, we will go to in Eclipse, go to help, install new software, hit add, and then copy paste this link. So let's copy this link and then go back to Eclipse and then go up here to help, go to install new software, and then we will copy paste the link. You'll hit a checkbox here and you'll hit next and then finish. That will install the software. You will then have to restart Eclipse and then it should appear in the top left corner of your screen here. So the big thing about the viewer canvas is that it can only be used for debugging. So you can't run your program and see what things are after runtime. So we first start by opening the viewer canvas before we begin debugging. And then it should pop up here. And then I usually like to drag this to the bottom right corner because it's out of the way. So then you hit debug, first put a breakpoint down, then you hit debug. Let's debug the driver. This is a linked list. That's what list is. And this is a binary tree. That's what tree is. All right, so let's pop this back up. And then we will start adding to list. So if we step over, we add 0 to list and we add 12 to list, but we can't actually see what's happening. So the big thing here to note is that with this canvas open, you click on your variable and you drag it over. Click and hold, drag, drop. You can drop your data structure into the viewer canvas. So here is the linked list with head pointing to 0 and 12. But let's say you have a way more sophisticated data structure and the stuff inside of your linked list, for example, is not as simple as a primitive. What you can do is you can click on it and you can actually drag it out and you can see the value. But let's say that you're on a Mac. I've heard that some people on Mac can't actually drag stuff out. So what you do is you right click on your variable and then you click view by value. Click that and then it should show up in its own unique window that will update whenever you debug your code. Of course, you can move this window around. So let's keep both open for both demographics, huh? All right, list. So let's try adding 22. So let's pay attention over here to the singly linked list. Let's add 22, and then we can see that 22 pops up, right? So we can see that, at least as of now, head points to the first node, whose element is 0, and the next is 12, element 12, and so on. So let's add the rest, add the remaining, and then remove. So let's say our remove isn't working. So let's go debug it. So we step in, make sure it's not empty, create a current that points to the head, and then we can see that current actually points to the node that head points to, which is this node right here. And if we really wanted to, we could drag out that node, but sometimes it doesn't work. It's a little finicky, but you just got to work with it. All right, so let's see if the index we're looking for is the first one. I believe we're looking for 22. So 22 is not the first one. And it's not the last one either, because that would be 61. So we start at 0. So now we parse through our singly linked list using a current node. So current is pointing to the first one. So if current.next.next is not null, then if it's the one we're looking for, but it's not, so we set current equal current.next. And if you look down here, you can see that current actually moves forward one space, just like it says on the code. So we add the current index plus plus, and then if the current.next.next is one we're looking for, which it is, then we create a new next that points to current.next.next. And we do that because obviously 12's next is going to be changed to 38. So that's exactly what we do. Current.setNext to new next. And then 22 will actually disappear on the screen. Decrement size by 1, and then we return true. All right, so that's how you debug a linked list. So let's drag this over here to the side, drag it out of the way, and let's delete this value here. That was from inside, that's this one. All right, so let's try this binary search tree. Let's debug over this, and then let's drag this out here, and then let's get rid of this, and then let's right click on the tree and view by value, right? You don't have to do this, it's only if the viewer canvas dragging does not work for you. All right, so let's see, we have our tree. So let's insert, well, let me pull off the tree first. Oh, all right, already did. All right, nice. All right, so let's insert 50. So because 50 is the first element, it becomes the root node. So then insert 40. 40 is less than 50, so we insert it to the left. And then we insert 45, left, right, and 60 is all the way to the right, and so on and so on. And we can see that we slowly get a full binary search tree. Well, it's not technically full, but it's a It is a binary search tree that is completed through the code. All right, so now let's say we want to test remove, just the same like we did in linked list. So we step into, and then we skip over this. It's a Java method, and then we step into this. All right, so remove is a recursive method, right? Almost all tree methods are recursive. All right, so we step into this, and then let's just go one recursion loop into this. So result equals node, and then we can actually see down here and to the left that there is a new node result pointing at 50. So if it's null, it's not. If it's smaller than, then we set node.setLeft over there. So get left and then move. So now we can see that node is now pointing to 40. And if we step into it, if it's null, if it's less than, if it's greater than, and luckily we found the one we're looking for, that's 40. Let's scroll down a bit here. So if the both children are null, then do something else, but they're not. So we will find the min between get left and get right. Or no, we're not doing that. We're finding the min of the minimum node from the right subtree of 40, and that's 45. So then we're going to set data equal to temp.getElement, temp being 45, as you can see in the bottom of the screen. And then we click that, and then that's what data is. And then we remove temp.getElement, which removes 45 from the tree. But we remove 45, but then we set 40s, this one, right? If we drag that out just as well so we can see it a little better, right? So we can do this, and then we can see value, and then we set 40's value equal to 45. Result equals node, and we return result. So that's how we use the JGrasp Canvas Viewer. I hope this helps you guys out, helped us out immensely on our Project 3 and Project 2, and it will definitely help us out, help everyone out on Project 4 when visualizing trees such as this one. All right, best of luck.